Betelgeuse, otherwise called a red monster star, would stretch out to the circle of Jupiter, assuming that put where the Sun is gigantic and entirely unsound, going to detonate. Famous researcher Brian Cox has given an intense admonition, provoking the inquiry. Are we going to witness a cosmic explosion blast that will change the night sky forever? We should make a plunge into the endlessness of the universe. Stars are conceived, live, and die in astounding ways. Recently, one star has grabbed the eye and worry of cosmologists and the general public. Betelgeuse, a red, very giant star in the heavenly body Orion. It is unimaginably huge and old, with a special ruddy tone and changing brilliance that have for some time been interesting. Recent events have elevated interest in this vast giant, showing we might be very close to a fantastic event in its history. What could these changes in Betelgeuse mean? Are we seeing the start of an enormous scene on an incredibly large scale? Betelgeuse is a heavenly monster, multiple times bigger than our Sun. Its size is nearly beyond human perception. Assuming that it supplanted our Sun, its surface would reach out past Mars' orbit, encompassing Mercury, Venus, Earth, and Mars. This giant size not only shows the actual greatness of Betelgeuse, but also demonstrates its stage in the heavenly life cycle. As a red, very giant Betelgeuse is approaching a mind-blowing finish, extending and cooling in the wake of depleting the hydrogen in its center and combining helium, the star is assessed to be somewhere in the range of 8 and 8.5 million years old. While generally youthful in human terms, it is ancient in heavenly terms. Over a long period, Betelgeuse has gone through emotional changes, developing from a hot blue star to the red monster we notice today. It is presently in its last stage as a red, very giant star, changing throughout its life because of the continuous tensions of atomic combination and gravity. Betelgeuse's interesting rosy variety emerges from its cooler surface temperature compared to other stars. Like our Sun, the Sun's surface is around 5,500 Kelvin, while Betelgeuse's surface is about 3,500 Kelvin. This cooler temperature permits Betelgeuse to emanate light at frequencies that cause it to seem red, revealing data about the star's actual state and the cycles happening inside its immense, vaporous volume. Verifiable records from Roman and Chinese periods show that Betelgeuse was yellow close to 1,000 years ago. By the 9th century, Arabic space experts noticed its red tone, connoting the star's development over time. Another fascinating aspect of Betelgeuse is its changing brilliance. As a semi-regular variable star, its splendor varies occasionally, spellbinding researchers and stargazers for a long time. Ordinarily, Betelgeuse goes through a multi-day cycle and a more extended 5-year cycle. Sir John Herschel reported these cycles as soon as 1836, and native people accounts might go back much further. Anyway, what genuinely makes Betelgeuse baffling isn't just its brilliance changes but their abnormality. Dissimilar to many stars that fluctuate in splendor regularly, Betelgeuse sometimes goes astray from this pattern, proposing intricate and less comprehended processes inside its gigantic structure. Recently, space experts and stargazers worldwide were stunned to notice a sensational and startling change in Betelgeuse's appearance, known as the extraordinary darkening. In late 2019, Betelgeuse began to diminish strangely, losing its light at a rapid rate. By February 2020, it was at its dimmest. Betelgeuse, typically noticeable to the bare eye even in regions with significant light contamination, turned out to be a lot fainter. This exceptional dimming raised various issues and concerns. Observing Betelgeuse activities is complicated, as mystery light from Betelgeuse requires right around 700 years to contact us, approximately 725 light-years away. This delay makes foreseeing and observing fast changes in its behavior challenging. The Great Dimming Event highlighted the difficulties of ongoing sky observation and our limited comprehension of the huge and baffling domains of existence they occupy. Andrea Dupree, Deputy Director of the Harvard-Smithsonian Center for Astrophysics, and her group closely monitored Betelgeuse's divine show. They utilized the Hubble Space Telescope to observe the enormous star as part of a 3-year study to follow changes in its external climate. These observations provided new insights into how a variable star like Betelgeuse works. Scientists analyzed the layers above Betelgeuse's surface, warmed somewhat by the star's whirling convection cells, thanks to Hubble's aversion to bright light. Further investigation of Hubble spectra taken at various times in 2019 and 2020 uncovered the development speeds in Betelgeuse's upper environment. The examinations showed that material was moving from Betelgeuse's surface into its air at around 200,000 miles per hour. This hot, thick material eventually formed a residue cloud that darkened the star during the 3 months of the eruption. Dupree and her group assessed that about twice as much material as expected was ejected from Betelgeuse's southern atmosphere. While all stars lose mass over time, Betelgeuse's mass loss was particularly remarkable since it happened at a much faster rate than the Sun's. Stargazers discussed whether this event could signal an impending cosmic explosion, given the extent of the mass delivery and the ensuing dimming. Being around 725 light-years from Earth, Betelgeuse adds to the interest, as any such blast would be noticeable from Earth and offer a rare chance to observe a cosmic explosion up close. Yet, this has yet to be addressed. What does this darkening mean for Betelgeuse's future? Is it an indication of an upcoming cosmic explosion? Or is it just a one-time event in the star's long and complex life? A few speculations have been proposed to make sense of this quick change. One well-known hypothesis proposed it was a precursor stage in the cosmic explosion process, building up momentum because of the belief that Betelgeuse is approaching the end of its life. Another common hypothesis suggested that dust, perhaps from the star itself, was obstructing our view. It is known that Betelgeuse and other red supergiants shed material, which could aggregate into a dust cloud sufficiently thick to block the star's light. A third hypothesis analyzed how changes in the star's photosphere, the apparent external layer, could influence its apparent splendor. Spectroscopic investigations demonstrated that Betelgeuse's effective temperature dropped, suggesting that the star might be dimming because of a large dark spot on its surface. The fact that Betelgeuse's temperature decreased by at least 170 Kelvin around the time of the dimming supported this idea. In the end, the Hubble Space Telescope helped us understand what was happening with this unusual event. Hubble's observations showed that the darkening of Betelgeuse was probably due to a lot of hot matter being catapulted into space, forming a dust cloud that darkened part of the star's surface. This dust cloud was believed to comprise extremely hot plasma that ejected from a massive convection cell on the star's surface. As this plasma traveled through Betelgeuse's hot climate to cooler external layers, it formed dust grains that made a cloud blocking light from about a fourth of the star's surface. Hubble's ultraviolet light spectroscopic investigations, which began in January 2019, were crucial in piecing together the events leading to Betelgeuse's dimming. These investigations identified thick, hot matter traveling through the star's environment long before the dimming. A few ground-based telescopes also noticed the star's splendor decline in December 2019, especially in its southern half. At first, the ejected material was more brilliant than the star itself, but as it moved outward and cooled, it turned into a foreboding shadow. This outflowing matter and the subsequent foreboding shadow were believed to be responsible for the abrupt darkening of the star. The blast was significant, putting Betelgeuse at the center of cosmic attention. The star ejected around 400 billion times the mass typically ejected in a normal coronal mass ejection. This material, thought to be several times the mass of the Moon, was significant for both Betelgeuse and our understanding of celestial cycles. What does such a massive ejection mean for theories about Betelgeuse and cosmic explosions overall? It has significant implications. Red supergiants like Betelgeuse are thought to lose mass at a relatively constant rate before they detonate at the end of their lives. However, the size of this discharge challenges this idea, suggesting a more violent and perhaps eccentric end-of-life stage for these stars. Could Betelgeuse be preparing for its grand finale, a cosmic explosion in a few thousand years? New studies speculate that such an event could happen sooner than previously thought, potentially within decades. Another significant aspect of the Betelgeuse puzzle is the concept of bow shock. This huge star moves through space at around 67,000 miles per hour relative to the surrounding interstellar material, creating a bow shock like the wave formed by a boat's bow moving through water. This impact occurs when the star's outer layers interact with interstellar gases and dust. It is a striking example of how dynamic the star is and how it interacts with its environment. The bow shock not only reveals Betelgeuse's current state but also provides insights into stellar evolution and mass loss. What about the star's ongoing behavior? Observations show that after the material launch, Betelgeuse's surface cooled and became less dense, suggesting that the star remains unstable years later. Hydrodynamic models connect the star's convective activities, the mass discharge, and the resulting change in throbbing mode. This continuous instability raises questions about the internal processes at play and how they could lead to the star's ultimate fate. While Betelgeuse will probably continue to shine brightly in the night sky for the foreseeable future, its new eruption of activity serves as a reminder of the dynamic and often unpredictable nature of our universe. For researchers, it highlights the importance of continuous observation and study, providing a wealth of information that may ultimately help us understand these titanic celestial phenomena. The uncertainty surrounding Betelgeuse underscores the need for further research and ongoing monitoring. While a cosmic explosion would be a stunning sight and a unique scientific opportunity, it would also be a rare event. If it were to happen, it would illuminate the night sky, making Betelgeuse visible even during the day for a while or months. Such an explosion would provide invaluable information on the life cycles of stars and the mechanisms behind supernovae. The recent changes in Betelgeuse highlight the dynamic nature of our universe and the importance of scientific inquiry in understanding it. Whether Betelgeuse will detonate in our lifetime remains uncertain, but its behavior continues to dazzle and intrigue researchers and stargazers alike.